right, we have one more topic on some more derivative rules, and these are specifically for derivatives of e, exponentials, and the derivative of natural logs. We'll kind of split it up into two pieces. All right, so back from Algebra 2, recall, sketch the graph of the derivative of f of x. So we spent a lot of time in Algebra 2 talking about the graphs of exponentials and logs. Probably we spent, on exponentials almost 2 months talking about exponential functions. So exponential starts very low, starts slow, but then it grows very, very rapidly. Okay, so you should know the graph of e to the x. You're going to be asked to draw this probably on every quiz we have throughout the year. What else is not drawn in on this graph is that you should know the points that it crosses through. So if the x value is 0 and I substitute in 0, anybody to the 0 is 1. So you should label this point on every quiz, test, etc. We know the point 0, 1. And it also has an asymptote, which is not in this picture. You're going to have to draw in your own asymptote at y equals 0. So you can remember the definition of an asymptote is that this function is getting closer and closer and closer, but it does not touch. It just gets closer. So now we're asked to graph the derivative of this function. And the derivative is actually pretty neat. So what I'm going to do is I'm going to put some tangent lines in here in orange, and we're going to talk about the slopes. Because again, that's all a derivative is. Every time you see that word, you're just saying slope. Okay, so I'm going to draw some tangent lines. Remember, it just touches the graph once, and we'll kind of talk about these tangent lines. So what do you notice about the slope of all of these tangent lines that we drew here? Positive, negative, 0, hopefully saying they're all positive, which tells me that this whole graph is going to sit above the x-axis. Okay, the derivative will sit above the x-axis because all of the slopes are positive, and positive would be above the x-axis, negative would be below. So let's say we assign a value to this. I don't know, maybe you think this has a slope of, maybe this you think has a slope of 1/2. Would you say this gets steeper and steeper and steeper, so the slopes are getting higher? So let's say you think that right there we had a slope of 1/2. So we'll go ahead and plot that point at maybe a half. And then we know the slopes are getting steeper and steeper and steeper and steeper. And as I go back this way, the slopes are getting less steep, but they're still positive. So less steep means they're getting smaller and smaller and smaller, but they're still positive. The fact is the graph of the derivative, of e to the x is actually itself. The derivative of e to the x is e to the x. So again, I would want to label this point 0, 1 and denote my asymptote at y equals 0. So not too many functions when you derive them are the exact same thing. But e to the x, the derivative is e to the x. So of course there's rules that you're going to use a saying and talk yourself through. But we have derivatives of exponential functions with base e, of course, because they're exponential. This one where there's no chain rule, and this one with there is chain rule. So the derivative of e to the x, like I just showed you, is just e to the x. How convenient. Now, chain rule meaning there's something other than x here. So that's what I want you to denote. This u means something more than x. It could be 5x. It could be x squared plus 3. It could be the sine of x, but there's something more than x. So here's how you derive it when you have something more than x. You leave it alone, and then you multiply by the derivative of the exponent. And maybe we'll just kind of write that out for ourselves. You leave it alone, and then multiply by the derivative of the exponent. And it's pretty easy for the most part. So let's go ahead and practice some. We're just going to take the derivative. So the derivative of f of x, of course, is f prime of x. And so my rule for derivatives is e to the u times du. So let me just put the derivative of e to the u. Okay, the derivative of e to the u is e to the u times du. So in this case, I'll just kind of break it down for you. Who is the u? U meaning the exponent. The exponent is 2x squared. Therefore, the du, the derivative of u, power rule, gets me 4x. Therefore, the derivative of e to the 2x squared is, leave it alone, e to the 2x squared times the derivative of the exponent times 4x. And again, you could just pull that coefficient out in front, 4x e to the 2x squared, and you're done. So it's e to the u times du, leave it alone, times the derivative of the exponent. Example 2. It's more than just e to the x, so we're applying the chain rule. So again, I'm going to say the derivative, and you don't have to write it every time, but I will for the time being. The derivative of e to the u is e to the u, leave it alone, times du, the derivative of the exponent. So I guess I'm just going to ask myself, who is the exponent? Who's in the u spot? That's sine of x. Therefore, its derivative, the derivative of sine is cosine of x. So the derivative of f of x, so f prime of x equals, leave it alone, times the derivative of the exponent, times the cosine of x. Now, if you can do all this in your head, you don't have to write it down. I'm just trying to really show the basics for everyone about who the u is and how to derive it. But if you can do it all in your head, that's fantastic. So give number 3 a whirl. E to the 2x minus 3x squared. Pause it and give it a try. So I did mine for you. I have f prime of x, so I equals, leave it alone, times the derivative of the exponent, which is just a quick power rule. That's linear, so 2 minus 6x. And again, really the only thing you can do is bring it in front. Please take note of the brackets or parentheses. You do need that around there. All right, f of x equals e to the cosine of 7x cubed. All right, so same idea. I'm just going to jot down my u for myself because there is a chain rule in there. It's the cosine of 7x cubed. And just again, to review that chain rule, this is my inside, this is my outside. So remember, I'm saying derivative of the outside. It starts with the c, so we know it's negative sine, keep the inside, times the derivative of the inside. So that is what I get for my du. So my derivative, f prime of x, equals e to the u, leave it alone, times the derivative of the inside. And then I'm just going to clean that up, of course, because I don't want to leave a negative here. You never, whoops, I didn't mean to hit that. You never want to leave that negative in the middle of a problem. That should be negative. It's always got to get pulled out front. So my final answer is going to be negative 21x squared e to the cosine of 7x cubed times the sine of 7x cubed. All right, a very similar one. Again, try it on your own, and then we'll compare. So I've got my final answer here, so I left it alone. Then I derived the outside became cosine, keep the inside times the derivative of the inside. And then, of course, I just pulled that constant out in front. And again, the order of these two doesn't really matter, but the constant should come out front with that 45. All right, now this one gets a little sneakier. So it's still, obviously there's more than x, so we know there's a chain rule up here. But now read it out loud. Notice this says x, there's two x's, x times the sine of x. So I have x, oops, that's a little too thick. I have e to the x sine of x, so I have in there, I'm sorry, I'm just not happy the way I'm writing this. All right, third time's a charm here. I have x times the sine of x. So notice how I said times. So when I derive that, I'm going to need to use product rule. So my u in this case is x times the sine of x. So I'm going to go ahead and take my du with product rule. First times the derivative of the second plus the second times the derivative of the first, which is 1. I don't really need to write it. But that would be my du. So my derivative would be e to the u times the du. Okay, so e to the u times du. And again, these parentheses are very important because there is a plus sign in here. One last question to tackle with our exponentials before we hit the logs. I have e to the negative 5x times the cosine of 2x. So the u itself in my e function here does not have a product rule, but the actual function here is e to the 5x, negative 5x times the cosine of 2x. So I do have a product rule. I have 2 chain rules because this is the cosine of 2x. So you'll notice sometimes they don't put the parentheses around the trig part for you if they're taking the sine or cosine of. So you do have to be quick enough to put those in there. So I'm just going to write both functions out. One function is e to the negative 5x, and the other function is the cosine of 2x. Those are my 2 functions that I'm finding the product between. So if I derive e to the negative 5x, I get, leave it alone, e to the negative 5x times the derivative of my exponent, so times negative 5. If I derive cosine of 2x, that's my inside and my outside, I get negative sine of 2x times the derivative of the inside times 2. So now I'm going to go through my product rule. So it's the first term, so f prime of x equals the first term times the derivative of the second, which is this guy. I'm just going to clean it up and rewrite it as negative 2 sine of 2x, plus the second term times the derivative of the first, which is negative 5 e to the negative 5x. Okay, so calculus-wise, it's done. Again, they could have fun, and they probably will if it's multiple choice, pulling out a GCF with you. So it looks like, here's my plus sign, right? So I'm looking for something on this side and this side that are the same. And I would say they both have an e to the negative 5x. So I'm going to pull that out as the GCF. So I'm taking that out. So I have negative 2 sine of 2x. And I'm taking this out. So I would say minus 5 cosine of 2x. Okay, and that would be my cleaned up version. All right, our second part we're going to talk about is natural logs. And we did talk about natural logs in Algebra 2 quite a bit. They're the inverse of the exponential function, and that makes them very important. So here is y equals the ln of x, and you should know this graph, and again, it'll be on most of your quizzes, and you should know that it passes through the point 1, 0. Remember, exponential pass through 0, 1, and since they're inverses, this is going to do the opposite, and it's going to pass through 1, 0. So you can see that it's only graphing positive numbers because you can only take the ln when x is greater than 0, so we don't have anything over in this negative section graphed. So let's stick some tangent lines on like we did with the previous graph, and we'll talk about their slopes. So would you agree this slope is positive and it starts pretty steep, and now it gets less steep and less steep and less steep and less steep and less steep. And again, it's just getting less steep, and it looks like it eventually is going to hit 0, but we know that it doesn't because this keeps growing and growing and growing. So if I were to plot that, I would say it's very, very steep the closer I get to the y-axis. So I would say it's very, very high. And then it gets less steep, so I'm plotting smaller points, and less steep and less steep and less steep. And again, it looks like it hits 0, but it doesn't actually because there's an asymptote. So our ln graph is going to look something like this. And I also want to make sure we have to note that there's an asymptote in here at x equals 0. All right, so let's tackle some rules for the derivative. So I'm not sure if you recognize that. I'm sorry, I jumped the gun here. If you didn't recognize that graph, that is the graph of 1 over x, only graphed for the positive numbers. So here is the rule. So the derivative of the ln of x is 1 over x. And here's the rule for chain. We call it du over u. Okay, so u is who you're taking the ln of, and on top you're putting the derivative of that function. Again, it's a pretty simple rule, and we'll walk through it in a few examples. So every time you see ln and you're deriving, you want to say du over u. So in this case, our u is the inside function, 2x cubed. And our du is who we're or the derivative of u. So it's just the power rule there. So I get 6x squared. And literally, you basically did the derivative, f prime of x. You just have to write it correctly. It's the du over the u. So it's 6x squared over 2x cubed. And then we can clean up. The 6 divided by 2 makes 3. X squared over x cubed puts an x in the denominator because the x cubed is bigger. So our final answer is 3 over x. We'll try the next one. Same idea. Every time I see ln, just remember du over u. So my u is who's ever inside those parentheses, my inner function. So I have x minus 5x to the fifth. Du means to take its derivative. X is linear, so its derivative is 1. Minus, there's my power rule. That's 25x to the fourth. And now you just write it correctly. F prime of x equals my du, 1 minus 25x to the fourth, over my u, x minus 5x to the fifth. Okay. Du over u. And that's all there is for ln's. Number 10, give it a whirl on your own. Pause it, try it, and we'll compare. So I identified my u and my du, and then I literally just wrote the du over the u. Now there's nothing to clean up because of this plus sign. You cannot simplify these x's here. It literally is just done because of that plus sign. All right. Number 11, f of x equals 7 ln of sine x. So my question is this product or not? How many x's do you see? Hopefully you're saying just one. So that is not a product rule because there's not another x. So 7 is just that coefficient. So that just comes along for the ride. Just leave it there. And I see an ln, so I'm saying to myself, I need du over u. So sometimes I start with the u, and I just write it in here. Who is my u in this case? Sine of x. And what is its derivative? Cosine of x. So I have 7 cos of x over sine of x. Now, they could get creative in the multiple choice answers because cosine over sine is a trig function we should know. So you might want to star this or highlight it in your notebook. Tangent is actually sine over cosine. And again, that's an algebra 2 topic we hit. Therefore, cosine over sine would be its reciprocal, which would be equivalent to cotangent. So they would most likely on the choices put cotangent in place of that. All right, number 12. Right off the bat, I'm going to read it out loud, and I see x ln of x, or x times the ln of x. And I noticed I said 2 x's, so I know I'm going to use that product rule. So I'm just going to kind of rewrite it for myself. I have x times the ln of x. Okay. So product rule, we're going back to that saying first derivative of the second plus second derivative of the first. So my first, I'm going to derive the second plus the second times the derivative of the first. So this one's pretty easy. The derivative of the first is just 1 because it's linear. The derivative of the ln of x, remember, is du over u. Who is your u in this case? Who are you taking the ln of? That's your x, and its derivative is 1. So ln of x doesn't really need a chain rule because it's 1 over x, but you can always apply it, du over u. Now I'm going to clean this up. This is really x over 1. So if I multiply, I have x over x, which of course is just 1 plus the ln of x. All right, I think that leads us to our last example here. So again, this says x cubed. Let's get rid of this plus sign. Obviously, I meant to put something there. Let's just get rid of this plus sign, okay? So I have x cubed, the ln of 3x minus 2. So again, I'm going to rewrite it as x cubed times the ln of 3x minus 2. So I said times, so why don't you pause it, try the product rule, and we'll compare again. But pause it and try it on your own. So I've set up my first derivative of the second plus second derivative of the first. This is an easy 3x squared over here. And I'm going to say it's du over u. My u is that 3x minus 2, and its derivative is just 3. So again, if I just wanted to clean that up, I have 3x cubed over 3x minus 2 plus 3x squared, the ln of 3x minus 2. And there's really nothing more we could do there. I would say we're good to go. So we've covered the derivatives of e's and ln's and the graphs that you should recognize, and we'll have a little practice to go along.